All right, let's open up the user's guide to our home planet, a world that's been around for about 4.5 billion years. Now, this isn't just a story about some random rock floating in space. No, this is more like a biography, the story of how this one complex system, totally against the odds, became the only place we know of that's actually truly alive. I mean, just let that sink in for a second. We have found thousands of planets outside our solar system, and there are probably billions, maybe trillions more out there. But so far, this little blue marble is it. It's the only one we're sure has life. That is a staggering statistical anomaly, isn't it? Just this one single, vibrant world in what seems like an endless, silent cosmos. So, what is the secret sauce? Was it just a lucky roll of the cosmic dice? Or was it a really specific sequence of events? The right ingredients, in the right place, at exactly the right time, that turned a barren rock into a cradle for life. Let's dive in and find out. Okay, so our story starts in pure chaos. About 4.5 billion years ago, the solar system was this violent construction zone of gas and dust. Earth wasn't born a paradise. It was a molten, totally inhospitable world. Its whole journey to becoming this habitable anomaly really hinged on one single ingredient. And that ingredient? It's water. Simple H2O. I mean, sure, we find ice on other planets and moons, and we see water vapor in other atmospheres, but Earth, it's the only place in our entire solar system that has stable, liquid oceans just sitting right there on the surface. And that's not just a nice feature to have. It is the fundamental prerequisite for life as we know it. It's the universal solvent, the cosmic soup where all that complex chemistry of life could get its start. 70.8%. That's a huge number. That is how much of our planet's surface is covered by its global ocean. And this massive liquid expanse, it wasn't just a backdrop for the story. It was the actual stage. It was right here, shielded from the really harsh conditions on the surface, that the first signs of life began to stir. But here's the thing, just having an ocean isn't quite enough. To keep that water around and protect whatever life is starting to form in it, a planet needs active, planetary-scale life support systems. It can't just be a wet rock. It has to have a pulse. And that pulse, it comes from deep, deep inside. You see, the Earth is dynamic right to its very core. We live on this super thin, cool crust, but right below us, there's a flowing mantle that literally drives the continents. And even deeper, there's a spinning, liquid outer core that acts like a giant engine, powering our planet's most critical defense system. And this is it, the magnetosphere, Earth's invisible shield. It's generated by that churning liquid core, and this magnetic field stretches way out into space, deflecting the sun's relentless solar wind. Without this shield, that stream of charged particles would have just stripped our atmosphere away and boiled our oceans dry. Earth would be as barren as Mars is today. So that shield protects our atmosphere, and while our air is mostly nitrogen and oxygen, I want you to look at that tiny, tiny sliver of other gases. It might not look like much, but it is doing some incredibly heavy lifting. This thin blanket of air is our second critical life support system, and its job is way bigger than just giving us something to breathe. You see, some of those trace gases, like water vapor and carbon dioxide, they create a kind of planetary thermostat that we call the greenhouse effect. They basically act like a natural blanket, trapping just the right amount of the sun's heat. Without that blanket, Earth's average temperature would be a frozen minus 18 degrees Celsius. But with it, we get to enjoy a comfortable plus 15, absolutely perfect for keeping our oceans liquid and our planet alive. So once all these systems were in place, the stage was finally set. But life didn't just passively exist on that stage. No, it became a geological force in its own right. It basically hacked the planet's operating system and started reshaping it on a global scale. This timeline really puts everything into perspective. You can see life showed up pretty early, but for billions of years, most of Earth's entire history, it was just microbial. The whole world of complex animals and plants, that's an incredibly recent chapter. And humans? Well, we basically showed up in the last few seconds of the last minute of this whole planetary day. And this quote gets at how life pulled off its greatest act of planetary engineering. Tiny little microbes figured out photosynthesis, and in the process, they released a waste product, oxygen. Now, for the life that existed at the time, this gas was pure poison. But over millions of years, it built up, triggering what we call the Great Oxidation Event. You could think of it as the planet's first ever pollution crisis. It wiped out a lot of existing life, sure, but it also created the oxygen-rich atmosphere that all complex animals, including us, would eventually need to breathe.
And that brings us to today, and to the planet's newest and by far the most rapidly acting force of change, us. After billions of years of being shaped by geology and microbes, Earth has now officially entered the human age.
This number really defines our era: 8 billion people. It's an incredible testament to our species' success, a success that was only possible because of the stable oceans, the protective atmosphere, and the balanced climate that we just talked about. But it's also the source of our unprecedented impact on those very same systems. And we can actually measure this impact. When you look at what's been driving the recent changes in global temperature, well, the data is just crystal clear. Natural forces, they cause blips, ups and downs, but they just don't account for the steady long-term warming trend we're seeing. That increase, about 1.2 degrees Celsius, is overwhelmingly, and I mean overwhelmingly, linked to human activity. We've basically taken control of the planet's thermostat. So, that leaves us right here. Earth's story is one of absolutely incredible transformation. From a molten rock, to a world terraformed by microbes, to a planet that eventually produced a species that can understand its own history. We are the first life form that actually knows how this planet works. The profound question now is, what are we going to do with that knowledge?